Hi, welcome to the series of video lectures on microwave engineering. Today in this session we will discuss microwave solid state devices, introduction and classification. This article comes in unit 6 of microwave engineering subject. Let us see very short or brief introduction of semiconductors, which we have studied in semiconductor physics and electronic devices and circuits. Let us see what is semiconductor devices. The semiconductors are a group of substances having electrical conductivities that are intermediate between metals and insulators. As we have studied in semiconductor physics and electronic devices circuits, that semiconductors are the materials which have electrical properties or electrical conductivities in between those of metals and insulators. The energy bands of a semiconductor play a major role in their electrical behavior. Some of the examples of semiconductor materials are silicon, germanium, gallium arsenide, gallium phosphide, indium phosphide, zinc oxide, etc. So these are the different semiconductor materials. Now, for each semiconductor, there is a forbidden energy region in which no allowable states can exist. So this is the general energy band diagram of a semiconductor device. So here this horizontal axis represents the interatomic distance and this y-axis represents the energy in electron volts. So you can see this is the forbidden energy band. So this is the forbidden energy band in which no allowable states can exist. Let us see in short about this energy band diagram of a semiconductor. The energy band above the forbidden region, is called as conduction band. The bottom of conduction band is designated as EC. You can see that the energy band above this forbidden energy band is called as conduction band. The lowest energy level of the conduction band is represented as EC. Similarly, the energy band below the forbidden energy band is called as valency band, and at the top of the valency band is designated as EV. See, the band below the forbidden energy band is called as valency band, and the topmost energy of the valency band is represented as EV. The separation between lowest conduction band and the highest conduction valency band is called as band gap energy, EG. The difference between EC and EV is called as energy band, which is represented as EG, which play important role in semiconductors. So this band gap between the conduction band and valency band will play a very important role in the operation of semiconductor devices. Let us see this band gap EG of different semiconductor devices. For silicon at 300 degrees Kelvin at room temperature, for silicon the band gap energy is 1.1 electron volts. For germanium it is 0.8 electron volts. For gallium arsenide, which is very important device in this unit, 6th unit, gallium arsenide, we have to remember this. Gallium arsenide, the band gap energy is 1.43 electron volts. For gallium phosphide it is 2.26 electron volts. So this one is very important, gallium arsenide. In this chapter we have to remember the band gap energy of gallium arsenide is 1.43 electron volts between valency band and conduction band. See, in this microwave subject already we have seen these microwave tubes. In microwave tubes are basically classified into two kinds: linear beam tubes. In linear beam tubes we have two cavity klystron, reflex klystron will come, and in cross field tubes we have seen magnetron, etc. All these microwave tubes can be used as either oscillators or amplifiers, which we have discussed in the microwave engineering. So now, similarly, the microwave solid state devices are becoming increasingly popular at microwave frequencies. See, similar to microwave tubes, these microwave solid state devices are increasing. The importance of microwave solid state devices is increasing day by day and at microwave frequencies. See, these microwave solid state devices are broadly classified into 4 groups. Let us see the microwave solid state devices and their classification. So these microwave solid state devices are classified into 4 groups: microwave transistor, field effect transistor, transferred electron devices, which is very important in this unit 16 unit, and avalanche transit time devices, which is also very important in this unit 16 unit. Now, so these are the 4 classifications: microwave transistor, field effector transistors, transferred electron devices, and avalanche transit time devices. So these are the 4 classifications of microwave solid state devices. As this microwave transistor and field effect transistor we have studied in the previous classes, but these are the construction of this microwave transistor and microwave field effect transistors are slightly different that we have studied in earlier classes, because these transistors, the transistor and field effect transistor, they operate at microwave frequencies, so their construction is slightly different from that of earlierly studied transistors and field effect transistors, but their operation is very much similar. So let us see the microwave transistors, their classification. Microwave bipolar junction transistor, which is called as BJT, heterojunction bipolar junction transistor, which is called as heterojunction bipolar transistor, tunnel diode. So under microwave transistor, these are the subdivisions. So field effect transistors, as you know that the field effect transistors classifications: junction field effect transistor, which is called as JFET, metal oxide semiconductor field effect transistors, MOSFETs, metal semiconductor field effect transistors, which are called as MESFETs, high electron mobility transistor, HEMTs, NMOS, N-channel metal oxide semiconductor, P-channel, PMOS, P-channel metal oxide semiconductor, complementary metal oxide semiconductor, CMOS, memories, charge coupled devices. These kind of transistors will come under field effect transistors. Now let us come to the transferred electron devices, which is very important. In this, the transferred electron devices, the classification is gun diode, limited space charge accumulation diode, LSA diode, limited space charge accumulation diode, LSA diode, indium phosphide diode, cadmium telluride diode, so that is CDTE diode. So these are the classifications of these transferred electron devices. Let us see the last one, avalanche transit time devices. In this avalanche transit time devices, we discuss about reed diode, impact diode. Impact stands for impact ionization avalanche transit time devices, trapad diodes, trapped plasma avalanche triggered transit time diodes, and barrier diodes, barrier injected transit time diodes. So these impact, trapad and barrier diode operations are very important in unit 6, and gun diode operation is also very. These 4 articles, this gun diode, these transferred electron devices and avalanche transit time devices are very important in unit 6, where this is all about this microwave solid state devices, a brief and short introduction of semiconductors, which we already studied in previous classes, and in this session we have also seen this microwave solid state devices classification. Thank you.